Hey everyone. Today, I'm going to walk you through a simple multi-agent framework using LangGraph. If that sounds a little technical, don't worry, I'll break it down. LangGraph helps manage AI workflows by structuring them into a graph, making it easier to coordinate multi-step processes, branching decisions, and interactions between different AI agents. Before jumping into the demo, let's cover some key concepts. You've probably heard the term agentic AI floating around. This refers to AI that acts autonomously, using tools, learning from experience, and adapting dynamically. But today, we're looking at something different, a multi-agent framework. Instead of one AI handling everything, this setup has multiple AI agents working together toward a common goal. Some agents are fully agentic, while others are more limited. For example, some AI models can generate responses but don't remember past interactions or make proactive decisions. These are considered non-agentic. If you're familiar with LangChain, you might know it as a popular AI agent framework. LangGraph builds on that by adding a structured graph-based approach, making it easier to manage complex workflows involving multiple agents. Now let's get into the demo. I've built a simple multi-agent framework, nothing too fancy, but structured enough to showcase its power. It includes 4 agents, all running on GPT-4o Mini. AI Expert specializes in AI concepts and their applications in education. Policy Advisor provides AI policy insights, complete with citations and source references. Quizmaster quizzes users, interpreting free text responses and adapting feedback accordingly. Cat Nutrition Expert, not because I'm obsessed with cats, okay, maybe a little, but to test if the framework can handle sudden topic shifts. If a query doesn't match any of these agents, the system won't just randomly assign one. Instead, it defaults to a general AI model to generate a response. So how does this actually work? At the core of the framework, 2 key components make everything run smoothly. 1, a reasoner node that decides which agents should handle a given question. 2, a tool executor node that runs the selected agents and compiles their responses into a final answer. While more complex structures can be implemented, this simple 2-node approach has proven to be highly effective. To see how the chatbot responds under different conditions, I first left all specialized agents off, relying only on the default AI model. I started with a simple question: is the Earth flat? Thankfully, it answered correctly. No wild conspiracy theories today. The response was factual and science-backed, exactly what you'd expect from a general AI. Next, I asked something more relevant to AI. How does AI differ from machine learning? The response was accurate but generic, a textbook-style explanation that lacked real-world context. So I activated the AI expert and asked the same question again. This time, the response was far more insightful, with examples from education, how AI helps institutions make decisions, and how ML powers adaptive learning tools like Newton and Carnegie Learning's Mathia. Rather than just defining terms, it provided context and applications. Here's how I knew the AI expert was in play. The response was more specialized. Real-world applications were included. It felt like an informed expert was speaking, not just a generic AI. Next, I asked, can students use AI for assessments? With just the AI expert enabled, the answer covered AI-powered grading tools like Pearson's scoring engine and Turnitin's revision assistant. It also touched on ethical concerns like academic integrity and bias. Then I turned on the policy advisor and repeated the question. Now the response included actual institutional policies, referencing universities that require AI disclosures or instructor permission. It even cited specific sources, like Duke University's AI guidelines and the University of Sydney's transparency requirements. Clearly, the AI expert and policy advisor worked together, combining technical AI knowledge with real-world policy insights. To test this further, I asked, what responsibilities do AI system owners have? This time, the chatbot provided a structured breakdown: risk management, compliance, governance, and ethical oversight, citing RMIT University's responsible AI procedure. This confirmed that the policy advisor agent was indeed pulling from actual policy documents. I tested my AI knowledge with a quiz. With no specialized agents, the chatbot randomly generated questions on the fly, and the formatting was inconsistent. Activating the Quizmaster immediately fixed this. The questions were now structured properly, pulled directly from my prepared dataset. Even the feedback improved. Rather than a simple correct or incorrect, it explained why an answer was right or wrong. At the end, I even received a performance summary across all my answers, something that was missing before. This proved how much more reliable the system became with the right agent in charge. What happens when I ask something completely unrelated? I asked, how much fat can I give my cat? Since no specialized agents were enabled, the chatbot defaulted to the general AI model. It gave a decent, generic response, saying cats need 20 to 30% fat in their diet and recommending healthy fat sources. Not bad, but pretty standard. Then, I activated the cat nutrition expert and asked the same question again. This time, the response was far more detailed, adjusting the fat range to 30 to 34%, which, yes, I double-checked in my knowledge base, and explaining omega-3 and omega-6 fatty acids, protein balance, and weigh-ins. This was a perfect example of multi-agent AI adapting in real time. Without the right agent, it gave a safe, generic answer. With the right agent, it pulled from specialized knowledge and delivered a much richer, more accurate response. And if nothing else, I now know exactly how much fat to feed my cat, so that's a win. Even though my custom agents are far from fully agentic AI, this demo proves that they can still work effectively together, all thanks to LangGraph's simple but powerful architecture. More importantly, this framework is highly extensible. It can be expanded by nesting this graph inside another for more advanced workflows, upgrading the reasoner node for better state management, adding new agents over time without breaking the system. This is what makes multi-agent AI so powerful. It creates a unified AI experience where users interact naturally while a team of specialized agents collaborates behind the scenes to deliver the best response. And the best part? This setup can grow gradually. You can start simple and keep building, adding new capabilities along the way. That's it for now. Thanks for watching, and see you next time.